Good morning, everyone. The ontology of services, like we were previously, we were discussing about these three types of ontology services. These three services are service profile, service model, service grounding. The service profile provides information about a service offered by a website, as well as service needed by a requester. An agent determines if the service meets its needs while satisfying constraints such as security, loyalty, and quality requirements. The service model enables an agent to to determine whether service meets its need, compose a service description from multiple services, coordinate the activities of different agents, and monitor the execution of the service. The service grounding specifies the details of how to access the service, such as protocol and message formats, serialization, transport, and addressing. The grounding is basically the inputs and outputs of atomic process. The current specification for this is available in DAML.org. In general, the service profile provides the information needed for an agent to discover the service, while the service model and service grounding objects provide the information for an agent to use the service. The properties each instance of service will provide a service profile, description, and a support description. We shall see these things one by one. First is service profile. A transaction in the web service marketplace involves three parties: the service requester, the service provider, and the infrastructure components. The service requester seeks a service to perform work, and the service provider offers a service. The infrastructure components are available to facilitate the process and include items such as registries to match the request with the available offers. Within the OWLS framework, the service profile provides a way to describe the services being offered and the services required. By using OWLS subclassing, it is possible to create specialized service profiles of services. The OWL service provides one possible representation through the class profile. A service profile describes a services as a function of three basic pieces of information: what organization provides the service, what functions the service computes, and what features characterize the service. There is a two-way relationship between a service and a profile that is expressed by the properties presents relates an instance of service and an instance of profile, and presented by specifies the inverse of presents. Service profile expresses two functions. First one is the information transformation, and second is the state change produced by the execution of the service. The information transformation includes the input and output properties of the profile. For example, a book selling service could require the buyer's credit card number and information on the book. The state change produced by the execution of the service results from the precondition and effect properties of the profile. Precondition presents logical conditions that should be satisfied prior to the service being requested. Effects are the result of the successful execution of the service. For example, to complete the sale of a book selling service requires a credit card number and expiration date, but also requires the precondition that the credit card account actually exists and is in good standing. The result of the sale is the transfer of book from the warehouse to the address of the buyer with a corresponding accounting transfer. In addition, the service profile provides a description of the service to a registry. Although the service profile and the process model play different roles during the transaction, they reflect the same service. And so the input output parameters and effects are related. The information is encoded in modeling primitives of OWLS classes and properties such as it is given here. Okay, it will be uh, encoded like represented like this. This table lists the profile properties to provide a description for the service on this class, such as service name, text description, and contact information. The profile of service provides a concise description of the service to a registry, but once the service has selected the profile, the client will use the process model to control the interaction with the service. Although the profile and the process model play different roles, they use the same input-output precondition and effects. This table lists the functional description parameters, additional information like such as guaranteed of response time or accuracy, cost of service, classification of service. Okay, these things are provided in this table. Okay, has parameter, has input, has output. These conditions. Okay, functional descriptions for the service profile is listed here in this table. You can see as input means it ranges over instances of input as defined by the process ontology, parameters input output instances. Okay, result, all these things will be functional description will be like this. Next, service model. Service model are based on the concept of processes that describe inputs, output, precondition, effect, and subprocess. A detailed perspective of a service can be viewed as a process. A subclass of the service model is defined as the process model that draws upon artificial intelligence, planning, and workflow automation to support a wide array of services. Okay, this following figure it shows the relationship of service model and includes the process and process control. Next, process model. The process model comprises subclasses and properties of the property class. The chief components of process model are the process ontology that describes a service in terms of its input, output, precondition, effects, and components of process, and the process control ontology, which deserves each process in terms of its state, including initial activation, execution, and completion. The process control model allows agents to monitor the progression of a service request as part of the process control ontology. Next, process ontology. Process ontology can have any number of inputs and outputs representing the information required for execution. Besides inputs and outputs, parameters for physical devices such as rates, forces, and control settings can be included. The process ontology serves as the basis for specifying a wide array of services on standardization. OWL This defines three types of processes: atomic, simple, and composite. Atomic means you can invoke it directly, simple, single step, but not directly invocable. Composite, composite means composable into other process. The atomic process can be invoked directly and are executed in single step. For each atomic process, there is grounding that enables a service requester to construct messages. A simple process are not associated with the grounding. They are single step executions. Simple processes are used as elements of abstraction. A simple process may be used either to provide a view of some atomic process or simplified representation of some composite process. Composite processes are decomposable into other processes. Their decomposition shows how the various inputs and outputs are accepted. A composite process must have composer of property, by which is indicated by the construct structure of the composite. The atomic process can be involved directly and are executed in a single step, for which atomic process there is a grounding that enables a service requester to control the message. The OWLS atomic process specify the basic action for large process and can also communicate the primitive of a process specification. Constructs. A composite process must have a composed of property to indicate the control structure using a control construct. Each control construct in turn is associated with an additional property called components to indicate the ordering and conditional execution of the subprocess. For example, the control construct sequence has a components property that ranges over process component. Okay, you can see in this table process construct, that is sequence, a list of process to be done in order, split. Okay, similar to like for concurrent, parallel, split plus join, concurrent, ordered, choice between alternative, executive, if then else, repeat until. Okay, these are few control constructs. Process control ontology. To monitor and control the execution of a process, an agent uses a model with three characteristics that provide mapping rules for the input state properties and preconditions to the corresponding output state properties. A model of the temporal or state dependencies described by constructs such as sequence, split and split plus join, and representation for messages about the execution state or atomic and composite process sufficient to do execution monitoring. This allows an agent to keep track of the status of executions, including successful, failed, and interrupted processes. Process ontology control is still an area under significant development. Okay, you can. Same thing is represented in this diagram. Next, service ground. Relationship between OWL service and WSDL and SOAP. In OWLS or WSDL, grounding involves complementary use of the two languages Both languages are required for the full specification of grounding. Even though there is some overlap, web services description language specifies abstract types using XML schema, but OWL services allows for the definition of logic-based OWL classes. In OWLS or WSDL grounding uses OWL classes as the abstract types of message parts declared in WSDL. The job of an OWLS or WSDL grounding is to define the messages and operations for the atomic process that are accessed and then specify correspondence. Because OWLS is an XML based language and its atomic process declarations and input output types already fit with a WSDL, it is useful to extend existing WSDL bindings for OWLS, such as the SOP binding. The OWLS concept of grounding is generally consistent with the WSDL concept of binding. The WSDL is used as a ground of an OWLS atomic process. Grounding OWLS with the WSDL and SOAP involves the construction of a WSDL service description with the message, operation, port type, binding, and service constructs. The OWLS grounding shows how the input and output of an atomic process are realized as messages in transmittable formats. Creating an OWLS ontology for web services. Creating an OWLS based ontology for a web service requires 5 steps. First one is describe individual programs. Describe the individual programs that comprise the service. The process model provides a declarative description of a program's properties. Describe the grounding for each atomic process. Relate each atomic process to its grounding. Describe compositions of the atomic process. Describe the composite process, that is a composition of its atomic processes. Describe a simple process. Describe a simple process for the service. Profile description provides a declarative advertisement for the service. It is partially populated by the process model. Next topic is semantic search technology. Today, searching the web is an essential capability, whether you are sitting at your desktop PC or wandering the corporate halls with your wireless PDA. As a result, the business of commercial search engines has become a vital and lucrative part of the web. As search engines have become commonplace tools for virtually every user of the web, companies such as Google and Yahoo have become household names. Recently, efforts have been made to implement limited semantic search by Google and other innovators. However, even with Google, it is common that searches return substantial and unwanted results and may well miss the important information that they need. Semantic search methods could augment and improve traditional search results by using not just words and concepts and logic relationships. There are two basic approaches to improving search results through semantic methods. Using first one is using semantic web documents, and second one is latent semantic indexing. So here, we'll be discussing about semantic search engines, semantic search agents, including their current development and progress, Google PageRank algorithm, a latent semantic indexing algorithm, and the web search application, that is TAppend's Supal, which will be discussed. Okay, search engine. A commercial search engine are based upon one or two forms of web searches technologies: human directed search and automated search. The human directed search engine technology utilizes a database of keywords, concepts, and references. The keyword searches are used to rank pages, but this simplistic method often leads to voluminous, irrelevant, and spurious results. In its simplest form, a content based search engine will count the number of query words that occur in each of the pages that are contained in its index. The search engine will then rank the pages accordingly. More sophisticated approach take into account the location of the keywords. For example, keyword occurring in the title tags of the web page are more important than the tags present in the body. Other types of human directed search engines like Yahoo use topic hierarchies to help to narrow the search and make the search results more relevant. These topic hierarchies are human created. Because of this, they are costly to produce and maintain in terms of time and are subsequently not updated as often as the fully automated systems. The fully automated form of web search technology is based upon the web crawler, spider, robot, or agent, which follows hypertext transfer protocol, links from site to site, and accumulate information about web pages to create a complex indexing system for storage. This agent-based search technology accumulates data automatically and is continuously updating information. Note that the information is automatically collected as links to words, not as meaningful concepts, as would be expected from a semantic web application. Current search engines are based upon huge database of web page references. There are two implementation of search engines: individual search engines and meta searches. Individual search engines like Google compile their own searchable database on the web, while master searchers do not compile databases but instead search the databases of multiple sets of individual search simultaneously. Next, ranking and relevance, like web page ranking and all. This topic we shall take up in the next class from here. Okay, about continuation of search engines. Right now, I'll stop here. All of you, please mark your attendance. Okay. From this topic, we shall continue in the next class. Mark your attendance, all of you. Quickly mark your attendance. We shall continue in the next class. Tomorrow I will take. of services. The OWL